CH2 came down, that's I, and then CH2, CH, Br, and then CH2, CH2, CH, came down, there's another I, and then another CH2, and then another CH2, and then a CH3. So what we first want to do when we look at this is we want to number how many there is. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that 9 is going to equal nonane. And so what we first want to notice is that there is a iodide in the first column and one in the sixth one, and then there's a bromide in the third. What we want to do is, because there's more than one halo group, we want to go alphabetically. So it would be 3-bromo, and then dash. We have our iodide in position 1 and position 6. So we write 1 and 6. We write dash, di, because there's 2 of them, iodo, nonane. And you should know that we get the nonane from the 9. We get the iodide. We get the iodide from iodide. We get the di because there are 2 of them. We get the position 1 and 6 because they are in position 1 and 6. We get bromo because bromo is right there, and it's in position 3, and we have to go alphabetically. So that's why it's 3-bromo, 1,6, di-iodo, nonane. So let's try an example with a cycloalkane. So if we had one that looks like this, CH comes down, CH2 comes down, CH2 goes across, C2H comes up, C2H, and then goes up, and then we had a fluorine, or fluoro, right there. So what we first want to do is we want to count how many hydrocarbons we have. So we have 1, 2, 3, 4, 5. And so we know that 5 equals pentane. Then the second step we want to do is we don't need to do any positioning because excuse me, there is only one halo group and there's no other bonds connecting to any of the other positions. So we just can circle this, and F, we know that F equals fluoro. And then for our third step, we know that this is in a full circle. Well, they're all connecting, and it's going to be a cyclo. So now we've put it in, and we write fluorocyclopentane. And there we go. There we have our cyclopentane. Well, one that we've used is cycloalkane. So now for our final example, if we had one that looks like this, we want to go around and we notice that there are 2 carbons. So let's number their position 1 and 2. And what we also notice is that we have a bromine, or bromo. It's in position 2, so we can write 2 bromo. We also realize that we have a chlorine, so, and that's in position 2 again, so that's chloro. And we know that we have 3 fluorines, or fluoro if you prefer. And so we have to write 1, 1, 1, dash, dash, trifluoro. So now we know that we have to go alphabetically, and so we know that B comes before C or F. So we write 2 bromo. Then we write dash, and now we realize that C comes before F, so we write 2 chloro. And now for our second to last part, we know that we have 3 trifluoro, so we have to write 1, 1, 1, because in halo groups you can actually write their first position, and so excuse me, we finish it off with trifluoro, and then now we actually finish it off with noticing that there are 2 carbons, and so that is going to be ethane. So now we can actually write ethane because there are 2 carbons. So if we had another example that was written like this, trichloromethane, commonly known as chloroform, or chloroform. So what that is going to look like is CH3. Oh, what is that? What that is going to look like is CHCl3. The reason why is because we have our 3 chloro, so our trichloro, and we have our 1 hydrocarbon, and that is equal to methane. So if we had another example that was 1, 3, 5 dash tri bromo cyclohexane. What that is going to look like is, let's change the color. We're going to draw our octagon, or not our octagon, but our hexane. And so it's going to look like this. Then we're going to have our CH2. We're going to fill in our hydrocarbons. CH, C2H, another CH, and then CH up here, and then a C2H. Then we're going to have some attachments or some bonds connecting, so Br, and then another Br, and then another Br here. So what we first want to do when we do this is number, like always. So 1, 2, 3, 4, 5, 6. And so we know that this is correct because we have our number 1 bromo in the position 1, our third bromo in position 3, and then our 5th bromo, position 5. Our tri is because there are 3 bromos, so we do tribromo, and then the cyclohexane is because it's connecting all together. So there you go.
Made with Doodlecast Pro.